Functions. If you want to check out a cool video associated with today's lesson, go to the Today button and click on this link. As we've been mentioning so far in our discussion, that a function is something that relates an output to an input. So it's kind of like a little computer. If you plug in some numbers, and depending on how you program the computer, you'll get a certain type of output. For example, here's three little equations that look like a little computer program, if you will. And if we input the number 5 into each one, like this, for the number x, out will come a different value for each one, because each equation is a little bit different, or I could say the function rule is different in each case. So when I crank out the numbers, I get 20 minus 1, which is 19. For the first one, the second one is 10 minus 5, that's 50. And the last one ends up being 7 minus 15, which is negative 8. Now for a problem like this, you actually plug in different numbers into this equation. So you're going to plug in 4 different numbers into this equation and determine what the output is. So that could look something like this. I'm plugging in the numbers 2, 5, 6, and 9. And when I do that, I end up with 4 plus 2 is 6, 10 plus 2 is 12, 12 plus 2 is 14, and 18 plus 2 is 20. So here's another one that's a little different. Let's try this one. So we're going to have 4 plus 2 times 3. 2 times 3 is 6. 6 plus 4 is 10. On our next one, we're going to have 4 plus 2 times 5. 2 times 5 is 10, and 10 plus 4 is 14. On our next one, we got 4 plus 2 times 6. And 2 times 6 is 12. 12 plus 4 is 16. You can almost see a pattern setting up here. Then for our last one, 4 plus 2 times 7. So if you're asked to do a question on this, or like this, this is what you do. 2 times 7 is 14. 14 plus 4 is 18. Okay, good. All right, so you remember from earlier in the year when we were talking about the equation y equals mx plus b. Well, we were really introducing you to a function, what we called a linear function. Y is the output, then the equal sign. Then we had m, which is the slope or rate of change, in front of x, and x is the input, plus b, which is the y-intercept or initial value of our equation. And so let's see how that works. Remember, the slope is the change in y over the change in x. So if we gave you a line or a couple of points on a line, you could do a little bit of counting and determine the change in y over the change in x. So here's what we want you to do with this information. So I've given you 4 dots on the line here, and we need to determine first the slope. So let's just pick a couple of dots. We have to go over 1 and up 2, over 1 and up 2. So remember, the slope is the change in y over the change in x. And when we have 1 on the bottom, we can just simplify that to be 2. The y-intercept is where the line crosses the y-axis, which in this case is at negative 1. So now we write the equation y equals 2x minus 1. So we've used this data to write a linear equation or linear function that represents these dots. All right, let's try another one. Now this is laid out a little bit differently than the last one, whereas the x and y values are laid out horizontally versus vertically. And remember, we have to do them in the right order. So the change in y, if I look from one pair of numbers to the next, go from 5 to 2, I'm going down 3. If I go from 2 to negative 1, that's a decrease of 3. From negative 1 to negative 4, it's another decrease of 3. So I'm dropping by 3 in the y direction. What about in the x direction? To go from negative 1 to 0, we're adding 1. To go from 0 to 1, we're adding 1, and so on. So each step we go to the right, we're going up by 1 in the x direction, but down by 3 in the y direction. So the slope is going to be negative 3, or negative 3 over 1. What about the y-intercept? The y-intercept is where the x value is 0, where it crosses the x-axis, or crosses the y-axis. So when x is 0, the y value is the y-intercept. So now we just have to write the equation. Y equals the slope times x plus or minus the y-intercept. And since this is positive 2, we're going to put plus 2. And there's the equation of this set of data. Let's try a couple more of those. All right, so we're going to find the slope first. So the change in x, as I look through these points, it looks like I'm counting up by 1. So the change in x is plus 1 each step along the way. What about in the y direction? To go from negative 2 to 2, that's an increase of 4. To go from 2 to 6, that's a jump of 4. It looks like it continues that jump right on across there. So then our slope would be, our change in y would be 4. Change in x, 1. And then remember, our y-intercept is the y value when x is 0. So our y-intercept in this case is 2. And so we finish it off by writing the equation y equals 4x plus the y-intercept, which is 2. Pretty straightforward process. I think we need to do another one just to make sure, though. Let's start with the y-intercept this time just for the fun of it. We notice that when x is 0, what's the y value? 3. So the y-intercept is 3. Now let's check our change in y and change in x. To go from negative 5 to 0, and from 0 to 5, and 5 to 10, on the x side of things, I'm going up by 5 points. Meanwhile, on the y, we take a look at the y, we're going from 1 to 3, 3 to 5, 5 to 7. That's an increase of 2. So the slope is 2, and our increase on that was, on x is 5, so our slope is 2 over 5. So when we write our equation, we've got y equals 2/5 x plus 3. So that would be the equation of our line, or our function that describes this set of ordered pairs. All right, I think we got one more, and then we'll be just about ready to try a few of these for practice. So our change in x, up 2, up 2. So our change in x is add 2. Our change in the y direction, on the other hand, is minus 2, minus 2, and minus 2, all in the y direction. So our slope then is negative 2 over 2, which simplifies to be just negative 1. And then our y-intercept is where the x value is 0, the y value at that point is 2. So let's write our equation then. Y equals negative 1x plus 2. So this is starting to look easier and easier each time we do one of these. We just need to find the slope, the y-intercept, and write the equation or the function. So we're going to practice some of each of these types of problems on your ALEKS assignment number 72, solving and writing linear functions.